All right, problem 13 is a question about particle motion. And the question is asking, when is the particle furthest to the right? Another way of asking that is, when is the position at a maximum on the interval from 0 to 4? So like with any other max-min problem, if I can find a velocity function and do the sign analysis and find the maximum or where the maximum occurs, I'll have found my answer. So I have an acceleration function, 2t minus 7. I have an initial velocity of 6. If I know the velocity acceleration relationship, I can find the velocity by doing the antiderivative, t squared minus 7t plus c. And knowing v of 0 equals 6 enables me to find the constant. So my velocity function here is t squared minus 7t plus 6. In factored form, that's going to be t minus 6 and t minus 1. And that gives me critical numbers of 6 and 1. Since 6 is outside of our interval, I don't have to worry about that for this problem. And so really between 0 and 4, I only have one critical number, which is, I'll put it over here, 1. And at that point, the velocity is 0. Before that point, the velocity is going to be, if I plug in 0 or something of that, in this range, I get a plus, and something like 3 is going to give me a minus. And so I know that the object is moving to the right, and then it turns, and then it moves to the left. And so if I'm looking for when it is furthest right, my answer is B. All right, 14, you might be familiar to you. We did this in class a few days ago. Infinite geometric series, there's a formula for an infinite sum of a geometric series. It's the very first term over 1 minus r. So we have 3 halves divided by 1 minus my multiplication factor I can find by dividing any two consecutive terms. So I'm going to do 9/16 divided by 3 halves, which is 9/16 times 2/3, and that ends up being 3/8. So 3/8 is my r. Continuing to simplify this, I get 3 halves over 5/8. 3 halves times 8/5 is 24/10. 24/10 is 2.4 as a decimal. All of our answers are in decimal. C is your answer for 14. 15 we're going to skip for now. That's dealing with parametric equations, so we'll jump to 16. This is a limit problem. The first thing I should try is plugging in 0. I get e to the 0, which is 1 minus 1. 0 on top, 0 on the bottom. That's indeterminate. Great time for L'Hopital's rule. And in case you forgot that, the L'Hopital's rule is if the limit is indeterminate, then you can take the limit of the derivatives of the top and the bottom. So the derivative of the top is just e to the h. The derivative of the bottom is 2. Evaluating that limit gives me 1/2. B is my answer for 16.